This video is a complete guide to rules of integration and differentiation with their applications. In this video, you will learn the uses of all the rules of differentiation and integration. We will solve a number of problems for each rules of differentiation and integration, putting an emphasis on important rules such as chain rule and other rules also to clarify the doubts you might have. You will see how simply you can take the derivatives and integrals of given functions using the rules of these two important topics of mathematics. You will see how you can find the integrals of complex function using two techniques of integration, which are integration by parts and integration by substitutions, and where to use which of them. I will start the first part of the video, which is differentiation, after writing all the derivatives and integrals of the commonly used function. Please check the description box to get the total work of the video. Now we can start our first part of the course, I mean differentiation. You will understand the rules of the differentiation and apply them in a number of examples. At the end of this part, you will be given a number of unique questions to test your ability and why you may use all the rules of differentiation in a single question. So let's start this part with naming it. So differentiation. So first rule, we can consider constant rule, the first one. So constant rule. So according to constant rule, derivative of any constant is 0. So let's say we have a function f of x is equal to c, where c is any constant. So derivative of this function ddx of c, or we can write it like ddx of f of x is equal to 0. Let's do some example on this. So example 1, so let's say we have a function f of x is equal to 5. So according to this rule, derivative of 5 is 0. Example 2, our function for this example is, let's say, pi. Okay, so derivative of pi, you know pi is the number, so this is also 0. Example 3, so we have a function for this, and this is 3 pi squared. So derivative of this function ddx of 3 pi squared. Here see, pi to the power 2, which is a number, and when we are multiplying it with 3, this is also a number. So derivative of this function, which is a constant function, actually it is 0. Let's talk about power rule. So for power rule, and again our function, general function f of x is equal to x to the power n, right? So this is x to the power n. This n can be any number except for 0. So this n cannot be a 0. So and derivative of this function ddx of f of x is equal to what? First we need to write the exponent. So this is n, and then the variable x, and to the power n minus 1. So derivative of x to the power n is actually n times x to the power n minus 1. So do some example on this. So example 1, our function f of x is equal to x to the power 3. So derivative of this function x to the power 3 is equal to, first write the exponent 3, then variable, then this power minus 1. So it would be 3x to the power 2. Example 2, For example 2, we have a function which is square root of x. So derivative of this function, we can write square root of x as x to the power half. Actually this is x to the power half. So the derivative of this function would be, first we need to write power, right? So half x to the power this power half minus 1, right? So we can write it 1 over 2 x to the power negative half, right? 1 half minus half minus 1 is actually negative half. So we can simplify it 1 over 2, and this x to the power half is a negative half. This is in the numerator right now, because we can imagine we have a 1 here. Okay, so if we take it in the denominator, then we can write it square root of x. They're the same thing. Okay, so example 3. Function for example 3 is x to the power 3 over 2. So derivative of this function dx of x to the power negative 3 over 2 is, first write the power. Okay, so negative 3 over 2, then variable x negative 3 over 2, sorry, minus 1, right? Minus 1. So we can write 3 over 2 x to the power 2 negative 3 minus negative 2, right? So we can simplify it. We can write 3 over 2 x to the power 2 over, sorry, negative 5 over 2, and we can simplify it 3 over 2 and square root of what? Square root of x to the power 5. Okay, this is the answer for this question. Okay, what is the derivative of x with respect to x? I think most of you know that this is 1, but how it comes? If you don't know, then you can check it through this example. So example 4, f of x is equal to x, and we'll be differentiating this function with respect to x. So ddx of x, actually we don't have any power here visually, but we have a power which is 1. Normally we don't write 1, so we need to write 1. So it is 1 into our variable x, and our original power 1 minus 1. Okay, so it would be 1 times x is actually x. X to the power 1 minus 1 is 0. So that's why anything to the power 0 is actually 1. So this is how it comes. Okay, so now let's talk about constant multiple rule. So constant multiple rule. So let's say we have a function f of x is equal to c y. So here c is a constant, okay, and y is any function. This is must be a differentiable function shown, and this c cannot be a 0, right? Okay, so we can take the derivative of this function ddx of f of x. We can derivate it again ddx of c times y. So y is the function, and what we can do, we can factor out this c from the differentiation, and we can write c times ddx of y. So this is the general format of constant multiple rule. So let's do some examples. So our example 1. So for example 1, we have a function f of x is equal to 5x. So derivative of this function ddx of 5x is equal to, first we can factor out this 5, okay, from the differentiation, then we can write ddx of x. Okay, so from the last example, derivative of x with respect to x is 1, so we can write 5 times 1, actually 5. So our answer for this question is 5. Example 2, a function for this example is 3x to the power 3. Okay, so derivative of this function ddx of 3x to the power 3 is equal to, here 3 are constant multiple, so we can factorial first 3 ddx of x to the power 3, okay, and we can write 3 into, we can put a bracket to separate it. So derivative of x to the power 3, so this is a power rule, this is a like a power function, we need to use power rule. So first we need to write the powers, right? So 3 times variable x to the power 3 minus 1, right? So our final answer will be 3 times 3, 9, x to the power 3 minus 1 is actually 2. So this is the answer. Example 3, f of x is equal to pi x, okay. So derivative of this function ddx of pi x is equal to, see this pi is a constant, so constant multiple, so we can write it first, then ddx of x, x, and derivative of x, you know this already, is 1, so pi times 1 is pi. Let's talk about two other rules of differentiation, and they are sum and difference rule. Okay, so sum and difference rules. Okay, according to the sum rule, we can write sum. According to the sum rule, let's say we have two functions, f of x and another function g of x, and we are adding them and taking the derivative of these two functions, right? So we can write it according to this rule, ddx of f of x plus ddx of g of x, and again we'll be subtracting these two functions, and we can write according to the difference rule. We can write difference rule. So our function are f of x minus g of x. So, and we are taking derivative of these two functions. So we can write ddx of this function is equal to ddx of f of x minus ddx of g of x. Okay, so let's do some example based on these two two rules. Okay, so our first example 1. So we have a function which is y is equal to 1 over 3 x to the power 3 minus x square minus 1. So derivative of this function ddx of y, or we can write it as ddx of, now I'll be showing you all the steps, and later I'll be some kind of straightforward, and I believe that at this case you'll be understanding those like skipped line, okay. And if you want, you will be having this ability to write all these lines, right? So we can write it. So what is y? Y is equal to 1 over 3 x cubed minus x squared minus 1. Okay, so we can write them separately. ddx of 1 over 3 x cubed minus dx of x squared, because we have negative sign here, that's why I'm writing negative sign here, minus dx of 1, right? So first we have a constant multiple, right? So I can write it first, 1 over 3 ddx of x cubed minus ddx of x squared minus ddx of 1. Okay, so now I can write 1 over 3 x to the power 3 minus 1, right? So sorry, I need to write this power. So 3 x to the power 3 minus 1 is actually 2 minus, first I need to write the power 2 x to the power, so we have a power which is 2 minus 1 is actually 2, so we don't need to write this 2, and the derivative of any constant is 0, so I don't need to write this. So now this c and this c gets cancelled. Okay, the final answer would be x squared minus 2x. So this is our final answer, or if you want to simplify this, you can write x, this is a common factor, so x first bracket x minus 2, So this is the final answer for this question. Example 2. For example 2, our function y, which is equal to 3x squared minus 5x. So derivative of this function ddx of 3x squared minus 5x, we can write them separately. ddx of 3x squared minus, because we have a negative sign here, right, minus ddx of 5x, right. In both cases we have constant multiple, right, so we can write, taking this constant multiple out, we can write 3 ddx of x squared minus 5 ddx of x, right. So now I can write 3, I can put a first bracket to separate it, separate this differentiation. So I can write, first I need to write the power exponent 2, then variable x to the power 2 minus 1 is actually 1, so I don't need to write this. Then 5, first bracket, derivative of x with respect to x is 1. Okay, so the answer would be finally 3 times 2 is 6x minus 5. Let's do one more example. Example 3, and for this we have a function y is equal to 7x to the power 3 minus pi e to the power 7, right. I already told you that here c is a constant, right, and e to the power a number which is again a constant, and when we are multiplying it with pi, which is a number, again we are getting a constant. So finally it would be a number and constant number, and derivative of a constant number would be 0, right. So I can write them according to the this difference. I can write them separately without giving you the initial line. So ddx of 7x to the power 3 minus, we have a negative sign, ddx of pi e to the power 7. So you know, okay, dx of y, I can write in this way. So I can factor out this constant multiple. So ddx of x to the power 3 minus dd, okay, so everything is constant, right, so I don't need to write anything, pi e to the power 7. Okay, so I can write 7, first bracket, second times, first I need to add the power, right, so 3 x to the power 3 minus 1 is actually 2, then derivative of any constant is 0. Okay, so now I can simplify it. 7 times 3, 21 x to the power 2. So this is the answer for this question. Let's do one more example on this. So example 4. For this example, we have a function which is y is equal to square root of x minus 5 x to the power negative 7 over 2. Okay, so derivative of this function dx of y, I can write ddx of square root of x. Another way to write it, x to the power half, right, you know this. Then we have a constant multiple, we can factor it out initially. Then I can write ddx of x to the power minus 7 over 2. Okay, so derivative of x to the power half is equal to 1 over 2 into this variable x to the power half minus 1, right. Now minus 5 into, so derivative of x to the power minus 7 over 2 is, we need to use power rule, right, we have power exponential function, so negative sign as 7 over 2, and then x to the power minus 7 over 2 minus 1. Okay, so I can simplify this and I can write 1 over 2 x to the power 1 over 2, because half minus 1 is actually negative half. So then I can write 5, see this minus times minus is actually plus, so 5 times 7, 35, right, and in the denominator we have a 2, then x to the power again at 2, then 7 negative 7 minus 2, right? So we can simplify it a little further. 1 over 2 and square root of x, then plus 35 over 2 x to the power 2 minus 9 over 2, right? So we can write one more line to simplify it. Finally, 1 over 2 times the square root of x, then plus 35 over 2, then we have square root of, I can separate it clearly, so 2, and then square root of x to the 1 9, right? So this is the final answer for this question. Let's talk about two other important rules of differentiation, their product and quotient rules. So product and quotient rules. Quotient rules. So let's say we have two functions, okay, and they are u and v, and they are multiplied with each other. So when we are differentiating these two functions, what we are getting? So this can be found according to the product rule. So ddx of u v, this u and v two functions, okay. So derivative of these two, this is product rule. Product rule, according to the product, derivative of these two functions when they are multiplied with each other, it would be u prime b plus ub prime. And according to the quotient rule, when these two functions are one function is divided by another, in that case our derivative would be, so according to the quotient rule, so I can write ddx of u over b, okay, u over b is actually u prime b minus ub prime divided by b squared, okay. Here u is actually derivative of u and b, sorry, u prime is actually derivative of u and b prime is actually derivative of b. So example 1. So for example 1, we have a function which is y is equal to x ln of x, okay. So our u is equal to x, so derivative of u with respect to x, or I can write u prime is equal to derivative of x with respect to x is 1, you know this already, and b prime or db dx is equal to, okay, before this I need to label our b, and I can write b is equal to ln of x, right? So ln of x, derivative of ln of x is actually 1 over x, okay. So according to the product rule, I can write derivative of y with respect to x is, first I can write the general rule, so u prime b plus u b prime, right? So u prime is 1 and b is or b is ln of x, right? And plus u is x, right? And b prime is 1 over x. So this x get cancelled, and I can rewrite this answer ln of x plus 1. So this is the answer for this problem based on product rule, because these two functions, here we have one function algebraic function, this is logarithmic function, and they are multiplied together, okay. Example 2. So for example 2, we have a function which is y is equal to 4x cubed minus 3x squared and divided by 4x to the power 5 minus 4. example 2. For example 2, we have a function which is y is equal to 4x cubed minus 3x squared divided by 4x to the power 5 minus 4. So let our u is equal to 4x cubed minus 3x squared. So u prime or du by dx is equal to, so here we have constant, we need to use constant multiple rule plus power. So 4 times, so I need to divide this, so it would be 3x to the power 2, 3 minus 1 is actually 2, and minus 3 times 2x to the power 2 minus 1 is actually 1, so I don't need to write this. And the final answer would be 4 times 3 is 12, 12x to the power 2 minus 3 times 2 is 6x. Okay, and our b is equal to 4x to the power 5 minus 4. So b prime or db dx is 4 times 5, 20x to the power 5 minus 1 is 4 and minus 0. Okay, so we do have all the things to differentiate this function y. So dy dx is equal to, so first I can write the this product rule formula. So u prime b plus u b prime, right? So I can write this is equal to, what is u prime? U prime is 12x squared minus 6x. Then b is 4x to the power 5 minus 4, and then plus, what is u? 4x cubed minus 3x squared into b prime, which is 0. Okay, sorry, this is not 0, this is actually, so 20x to the power 4, right? So I can simplify this. This 12 into 4. 12 times 4 is, this would be 44, I think. So 12 times 4 is 48. So 48, and here we are multiplying these two terms, right? So x square x to the power 5. In case of multiplication, we need to add power, right? So 5 plus 2 is 7, and this was plus into plus is actually plus. Then 6x times 4x to the power 5. So we can add, here we have a negative sign, plus sign, so plus into minus is actually minus. So 6 into 4 24. Then x to the power, here we have a power 1, which is 1. This is not visible. So 1 plus 5. So 5 plus 1 is actually 6, right? Okay, then next part. This is plus, this is minus. So minus 4 times 12. So 48x squared. And then minus times minus plus 6 into 4. 24. So 24 x to the power 1. So I didn't write 1. Then plus 4 times 20, 80 x to the power, here 3 and here 4. So 4 plus 3 is 7, right? Then minus times plus minus 20 times 3 is 60, x to the power 4 plus 2 is actually 6, right? So we can write the second line. So here you need to check one thing. So we are getting 40x to the power 7 and 80x to the power 7. So 48 plus 80, right? So 128. So 128 x to the power 7. Okay, then we have 24x to the power 6. We have 60 minus 60 minus 20. So 60 plus 20 is actually 80. So I need to remove this. So it is 80. Like 60 plus 24. So it is 84. So 84 x to the power 6 minus 48 x squared plus 24x. So this is the answer for this question. So according to the quotient rule, I can write ddx of u divided by b. I am writing the general rule, so it would be u prime b minus b or ub prime divided by b square. So derivative of this function, so I don't need to write it again, just remove them. So putting those values, I can write u prime is 12x squared minus 6x into, and now b, what is b? B is actually 4 x to the power 5 minus 4, right? Then minus u, what is u? 4x cubed minus 3x squared, and then I need to multiply it with what? B prime. So b prime is 20x to the power 4. Okay, so then in the denominator we have b squared, so 4x to the power 5, right, minus 4 squared. So we need to simplify this expression. So 12 into 4, how much? 48. So I need to make a big line. So 48 x to the power, here we are multiplying 2 times, so we need to add the power. 2 plus 5 is actually 7. Then what we can do, so 12x x squared into 4, so it will be minus 12 into 4, 48 x to the power 2, right? Then we have negative 6 into 4, 24 x to the power, here we have power 1, so 5 plus 1 is 6, right? Then we can minus times minus plus 24 x to the power 1, so I don't need to write this one. So then minus 4 times 20, how much? 80. So it would be 80x. 4 plus 3 is actually 7. Then minus into minus plus 20 times 3 60. 60 x to the power 4 plus 2 is 6. And in the denominator I can write 4x to the power 5 all to the power 2 minus 2, 4x to the power 5 times 4 plus 4 squared. We need to simplify this expression. I can write, so see, we have plus 48x to the power 7 and minus 80, so we need to subtract this, so it would be 32. So negative 32 x to the power 7, right? Then we have 60 x to the power 6 and 24 x to the power 6. How much? So 60 minus 24, it will be 36. So minus plus 36 x to the power 6, right? Then we can add minus 48x squared, then plus 24x, right? In the denominator we have 4 to the power 2 is 16, so 16 x to the power 5 times 2 is 10, right? Minus 2 times 4 is 8, 8 times 4 32 x to the power 5 and plus 16. So this is the final answer for this example. Example 3. For example 3, our function y is equal to x hyperbolic sec of x. So let our u is equal to x, right, and u prime or du dx is equal to 1, right, and our b is equal to hyperbolic sec of x, and derivative of this function db dx or b prime is equal to minus hyperbolic tan of x times hyperbolic sec of x. Okay, so we do have everything right now to solve this problem. So according to the product rule, I can write d dx of y is equal to, first we need to write the u prime. So u prime is 1 times b. So what is b? Hyperbolic sec of x, right? Then we need to put plus sign, and now our u. What is u? U is x times b prime, which is minus hyperbolic tan of, sorry, this will be h, hyperbolic tan of x times hyperbolic sec of x. Okay, so we can simplify it a little further. Hyperbolic sec of x, this is x, and then minus x hyperbolic tan of x times hyperbolic sec of x. So this is the final answer for this question. Yeah, we can do one more thing. We can take a common factor. This is hyperbolic sec of x, then we are left with only 1 on the left side, so 1 minus x times hyperbolic tan of x. Okay, so this is the final answer for this question. So example 4. So for example 4, our function y is equal to cos of x times sine of x. Okay, so let our u is equal to cos of x, and derivative of cos of x is equal to minus sine of x. Okay, and our b is equal to sine of x, and derivative of sine of x is equal to cos of x. Okay, so now we can differentiate this function according to the quotient rule. I can write d dx of y is equal to, first u prime, right? So minus sine of x times then b. What is b? This is sine of x, right? And then plus our u. What is u? U is cos of x times then b prime. So what is b prime? B prime is cos of x, right? B prime is cos of x. So we can simplify it. We can write sine of x times sine of x. It means sine of x squared plus cos of x squared, right? And according to the trigonometric identity, we can write this is equal to cos of 2fx. So this is a final answer for this question. It is time to talk about the most important rule, and sometimes students find it very difficult to understand. This is chain rule. So according to chain rule, first let me write the topic, which is chain rule, CHA, chain rule. Okay, so where we can use this rule? This is used actually in composite function. And what is composite function? When inside a function, if we have another function, in this case this function is called composite function. So composite function, according to composite function, I can write composite function. Okay, so composite function, how can we write this? So this is actually f of g of x. So if you see inside our f of function, we have another function, and this is g of x. So where we can write where g of x is inside function. So inside function, throughout this course I'll be taking g of x as inside function and f of x as outside function. So f of x is the which is the original function or the outside function, outside function. And let me show you one example of composite function. Okay, so example of composite function. Composite function is, let's say we have a function y is equal to ln of 4x. Here our inside function which is equal to g of x is equal to 4x, and our inside function which is f of x is actually ln of 4x. But when we are differentiating this outside function, we need to leave this inside function which is 4 of x as it is. So how can we differentiate this kind of function? Let me show you this thing. So according to the chain rule, I can write d dx of f of g of x. So here this g of x inside function, f of x outside function. First what we need to do, first take the derivative of outside function, derivative of outside function, and leaving the inside function as it is, and then take the derivative of inside function. Okay, so first you need to take the derivative of outside function. See this thing, leaving inside function as it is, and then take the derivative of inside function. Example 1. Our function for example 1 is y is equal to 5 minus 6 times x all to the power 2. So here our base is 5 minus 6, yes, x. So always in this kind of thing, or in case of exponential function, always take your base as in a function. So g of x is equal to 5 minus 6x, and outside function which is the original function is 5 minus 6 or 6 times x to the power all to the power 2. Okay, so derivative of this y, the dx of y is equal to, first we need to differentiate the outer function. So this is the outer function, and so here we have a power, so we need to apply the power. So 2 times, we need to leave the inner function as it is. So 5 minus 6x and 2 minus 1, so it is 1, we don't need to write this. And now differentiate the inner function which is 5 minus 6x. So derivative of 5 which is a constant is 0, and derivative of minus 6 is actually only 6, right? So the function, the answer would be minus 6 times 2, so 12, and 5 minus 6x. So this is our final answer for this question. Example 2. For example 2, our function y is equal to square root of cos of x. Okay, so derivative of this function d dx of square root of cos of x, we can rewrite it in a different way. We can write it d dx of cos of x, then all to the power half, right? So what is our inner function? See, this is our base, so this inner function is d of x is equal to cos of x, and our outer function f of x is equal to the original function cos of x all to the power half. Okay, so derivative of this function d dx of square root of cos of x is equal to, first we need to differentiate the outer function, so we need to apply the power rule here. So 1 over 2, leaving inside as it is. So cos of, we cannot do anything when we are differentiating the outside function. So cos of x, and then we need to differentiate the outside function, which is cos of x, right? So derivative of cos of x is actually sine of x. Okay, so the final answer, sorry, here I forgot to write one thing. So here we need to subtract our power half minus 1. So the final answer would be 1/2 cos of x all to the power negative half times sine of x, and we can write it more simply 1/2 then square root of cos of x, right, then sine of x. So this is our final answer. Example 3. For example 3, our function y is equal to cos of x squared. Okay, so here our inner function or g of x is equal to only this angle. Whatever we have in the angle, we need to take as our inner function. So we have x squared. So when your function is in place of angle, take your inner function including power. Don't leave this power. So our outer function is f of x is equal to the original function cos of x squared, right? So derivative of this function would be ddx of y is equal to, first we need to differentiate the outer function, right? So derivative of cos x is actually minus sine of x, but here we have x squared in place of x, so we need to write x squared, then differentiate this inner function, it would be 2x, right? Answer derivative of this function is 2x, so final answer would be minus 2x sine of x squared. Example 4. Function for example 4 is cos of x all to the power 2. We can derive it as cos of x all to the power 2. The same thing. They are the same thing. So our inner function here, this is our base. So take is as inner function. So g of x is equal to cos of x, right? And our outer function, which is f of x, is the original function. This is cos of x all to the power 2. Okay, so derivative of this function ddx of y is equal to, first differentiate the outer function, right? So first we need to 2 according to the power, so 2 times cos of x, right, and then 2 minus 1, so which is 2 minus 1 or just 1, and now differentiate the inner function, which is cos of x, and derivative of cos of x is actually minus sine of x. Okay, so final answer would be minus 2 sine of x then cos of x, and more simply according to the trigonometric rule, we can write this is minus sine of 2x. So this is the answer for this question. Example 5. So our function is y is equal to ln of x squared. So our inner function g of x would be this term. Okay, this is x squared, and outer function, which is f of x, it would be ln of x squared, right? So derivative of this function dy dx is first the outer function, right? So 1 over derivative of ln of x is actually 1 over x. So in place of x we have x squared. So x squared 1 over x squared times outer function, so which is 2x 2 minus 1 is 1, so I don't need to write this. So I can write it more simply 2x over x squared. Okay, x squared. So in the denominator we have 2x, in the numerator we have 1x. So one we have one one common multiple, so we can just uh, so derivative of this function dy dx is actually derivative of the outer function. So derivative of ln x is actually 1 over x, right? So 1 over x, in place of x we have x squared, and derivative of x squared, which is 2x, right? So x and 1x gets cancelled, so we are left with only 2 over x, right? So this is the answer for this question. And so example 6. For example 6, our function y is equal to 10x squared minus 3x minus, so it is plus 2 5 all to the power 2. Okay, so our inner function would be the base. Okay, so g of x is actually 10x squared minus 3x, right, plus 25, and our outer function is the original function, which is f of x is equal to 10x squared minus 3x plus 25 all to the power 2. Okay, so derivative of this function dy dx is equal to, first take the derivative of outside function, so we need to apply the power rule here. So 2 times the base, which is 10x squared minus 3x plus 25, and all to the power 2 minus 1. So we don't need to write this one. Now we need to take the derivative of the inside function. So 10x squared. So here we need to apply power rule and constant multiple rule. So we can take 10. Okay, then derivative of x squared is 2x, right? Then minus 3, derivative of x is actually 1, right? Then derivative of constant is 0. Okay, we can simplify this to 2 into 10x square minus 3x plus 25, then 10 times 2 is 20x minus 3. Okay, so we can simplify it a little further. So far I think it's fine, we don't need to do anything after this. Okay, then example 7. For example 7, our function y is equal to q minus 4. Okay, q minus 4 squared. Okay, so our inner base is our inner function, so g of x is equal to q minus 4, and f of x is equal to the original function q minus 4 all to the power 2. So derivative of y with respect to q, here our variable is q, so remember this thing. Normally we'll take x as our variable, but it is not correct always. We can take anything. Okay, so according to the situation we need to take our variable, so it will be given, don't worry. Okay, so derivative of this function is first outer function, so we need to apply the power rule. So 2 into x minus 4, this is inner function, we need to keep as it is, and then we need to differentiate the inside function, which is q. Derivative of q with respect to q is actually 1, and derivative of 4 with respect to, this is constant, with respect to q is actually 0. So our final answer would be 2 times q minus 4 times 1. So I didn't need to write 1. Okay, then we can solve one more example. Okay, sorry, this is 8. So our function for question 8 is square root of minus 2x squared plus 1. Okay, and we can write it in a different way, 2x squared plus 1 all to the power half, right? So our inner function would be So our inner function would be g of x is equal to the base, right? So minus 2x squared plus 1, and our outer function is f of x, which is the original function. We can write it as minus 2x squared plus 1 all to the power half. Okay, so derivative of y with respect to x is equal to, first we need to use the power rule. So we have a power, so 1 over 2, then we need to put our base minus 2x square plus 1, then half minus 1, then we need to take the derivative of our incident function, which is this part. Okay, this minus 2x, sorry, so derivative of minus 2x squared, it would be minus 2, derivative of x squared is 2x, right? Then derivative of 1, which is a constant, is actually 0, so 0. So final answer would be for this is 1 over 2, then half minus 1 is actually negative half, so we can write it simply in the numerator, minus 2x squared plus 1, right? Then we have another term which is minus 2 times 2 is 4x. So if you want to, okay, then 2 gets into 4 2 times, so our final answer would be minus 2x in the numerator, and in the numerator we have square root of minus 2x squared plus 1. Example 9. For example 9, our function y is equal to cube root of minus 2x to the power 4 plus 5. Okay, so we can rewrite it as minus 2x to the power 4 plus 5 all to the power 1 over. See, we have 3 here, so we need to write 3 here. Okay, so this is our base, so this is our inner function. So g of x is equal to minus 2x to the power 4 plus 5, and our outer function, which is our original function, which is minus 2x to the power 4 plus 5 all to the power 1 over 3. Okay, so derivative of y with respect to x is actually, first we need to apply the power rule. So 1 over 3, and we need to keep our inner function as it is, 2x to the power 4 plus 5, right? Then 1 over 3 minus 1 times derivative of the inner function, which is this part. So minus 2, derivative of x to the power 4 is 4, x to the power 4 minus 1 is 3, then derivative of 5 is 0. Okay, so I can write it simply 1 over 3, then square root of 1 over 3 minus 1. How much is it? 1 over 3 minus 1 is equal to 3, 1 minus 3, right? So we can write minus 2 over 3. Okay, so answer would be minus 2 over 3. So it would be minus 2 over 3. So I can write it minus 2 over 3. So minus 2x to the power 4 plus 5 all to the power 3. It means we have a 2 here. We have a 2 here. We don't write it normally, so I'm not writing it, but leave it as it is. Okay, then we have minus 2 times 4 is 8x to the power 3, and our final answer would be, minus 8x to the power 3 by 3 square root of minus 2x to the power 4 plus 5 all to the power 3. So this is the answer for this question. Example 10. So example 10, for example, we have a function which is y is equal to cos of ln of 7x to the power 5. So in place of theta, which is angle, we have ln of 7x to the power 5. So this is our original, inner function. So g of x is equal to ln of 7x to the power 5, and our outer function, which is f of x, is equal to this is original function cos of ln of 7x to the power 5, right? So if you check our inner function, here it is ln of 7x to the power 5. Here again we have one more in a function, this part, so 7x to the power 5. So let's say this is capital, sorry, this for this function, this inner function, we have another inner function, right? So this inner function, new inner function, g of capital G of x is equal to 7x to the power 5, and the outer function, which is the, like for this case this is the outer function, so this would be f of x, and this is ln of 7x to the power 5, right? So derivative of this function, it would be d dx of g of x is equal to, first we need to differentiate the outer function, right? So 1 over derivative of ln x is actually 1 over x, so in place of x we need to write 7x to the power 5, and then we need to differentiate the inner function, which is 7x to the power 5. This would be 7 times 5, 35, right? Then x to the power x to the power 5 minus 4, 5 minus 1 is actually 4. So 7 goes into 35 5 times, right? So the answer would be 5x to the power 4, right? Then x to the power 5. So in our numerator and denominator we have x to the power 4. This is a common multiple, right? So we can like so we can simplify this 5 x to the power 4 divided by x to the power 5. So in our numerator we have x to the power 4, and in denominator we have x to the power 5. So in numerator and denominator we have a common multiple, which is x to the power 4. So from both from numerator and denominator we will remove x to the power 4. So in the numerator we have 5 only, and in the denominator we have only x, right? Because x4 from both sides gets cancelled. Okay, so this is our like derivative of the original inner function, this much. Okay, so now we can take the derivative of y. So d dx of y is equal to, first we need to take the derivative of the outer function, right? So which is derivative of cos of x is actually minus sine of x. So minus sine of in place of x we have ln of 7x to the power 5. So ln of 7x to the power 5. So this is the derivative of outer function leaving the inside function as it is, and the derivative of inner function, which is g of x, we have taken it already, which is 5 over x. So our final answer would be negative 5 over x, right? Then sine of ln of 7x to the power 5. So this is our final answer for this question. Now we will be solving some examples to take the derivative of inverse hyperbolic and inverse trigonometric functions. So let's start with this topic. Inverse trigonometric and hyperbolic functions. So first example from this, example 1. So for example 1, we have a function f of x is equal to inverse sine of x, so 2x. Okay, so here our inner function is g of x is equal to 2x. Our outer function, which is the original function, which is sine inverse sine of 2x, right? So derivative of this function, everything is fine. So d dx of f of x is equal to, so derivative of inverse sine of x is equal to 1 over square root of 1 minus x square, but here in place of x we have 2x, so 2x all to the power 2, and now we need to differentiate the inner function, which is 2x. The derivative of 2x with respect to x is only 2. So final answer would be 2 over square root of 1 minus 4x squared. Okay, so example 2. For example 2, our function is inverse cos of 7x, and again our inner function is 7x, and outer function, which is the original function, inverse cos of 7x. Okay, so derivative of this function with respect to x is equal to, first derivative of inverse cos of x is actually minus 1 over square root of 1 minus x squared. So here 7x squared, right? Then derivative of inner function 7x is actually 7. So answer would be minus 7 over square root of 1 minus 7 squared is actually 49, then x squared. Okay, this is the answer for question 2. So example 3. For example 3, we have a function which is f of x is equal to inverse sine of x minus 4 inverse tan of x plus inverse cot of x. Okay, so derivative of this long expression is dx of f of x is equal to, according to the sum and difference rule, we can take derivative separately. So I can write dx of inverse sine of x minus, here 4 is a constant multiple, so I can factor it out from the differentiation. I can write f of dx of inverse tan of x, right? Then I can write the last term, which is dx of inverse cot of x. Okay, so I can take the derivative of these functions. Okay, so derivative of inverse sine of x is actually 1 over square root of 1 minus x squared. Okay, then here we have 4, and the answer, the derivative of inverse tan of x is actually 1 over 1 plus x squared, and then derivative of inverse cot of x is actually minus 1 divided by 1 plus x squared. So if you check these two terms, so here we have the, here they are like terms, so here we have 4 times, here we have 1 times, so we can add them together. So 1 over square root of 1 minus x squared minus, we have 4 times, here we have 4 times, here we have 1 times, 1 terms, so we can add them, so it would be 5 divided by 1 plus x squared. So this is our answer for this question. Example 4. So example 4, for example 4, we have a function which is y is equal to inverse cos of minus 5x to the power 3. Okay, so here our inner function, or g of x, is equal to minus 5x to the power 3, and our outer function, which is the original function, is inverse cos of minus 5x to the power 3. So derivative of this function dx of y is equal to, first we need to take the derivative of outside function, leaving the inside function alone. So I can write inverse of cos of x is actually 1 over square root of 1 minus 1 minus x square. Here it is 5x to the power 3 squared, and then derivative of the inside function, which is minus 5, then minus 5. I can take the derivative of x cube, which is 3x to the power 3 minus 1 is 2. Okay, so Here we are getting one negative sign, one negative sign. So one minus times minus is actually plus. So 5 plus 5 times 3, which is 15. 15 x to the power 2 divided by square root of 1 minus 5, 5 to the power 2 is 10. Sorry, it is 25. Sorry, 25, and x to the power 3 times 2 is 6. So this is our final answer for this question. And we can do one more example. So example 5. So example 5. So for example 5, we have a function which is f of x is equal to inverse sine of 5x squared all to the power 3. Okay, so our inner function which is the base, so it would be g of x is equal to inverse sine of 5x squared, and our outer function which is the original function which is inverse sine of 5x squared all to the power 3. So derivative of this function would be dx of f of x is equal to, first we need to differentiate the outer function. So we need to apply the power rule here because we have a power. So 3 times we need to write the base sine, inverse sine of 5x squared. Okay, then 3 minus 2 is equal to 2. Then derivative of the inside function which is inverse sine of 5 of x. Here see, we need to apply the chain rule again. So this is our inner function, this is our outer function, right? So try to understand. So I can put a third bracket here. So here our outer function is inverse sine of 5x squared. So a derivative of inverse sine of x is actually 1 over square root of 1 minus x squared. Here we have 5x squared. Okay, and then we need to differentiate the inner function which is 5x squared. The answer would be 5 times 2 x to the power, this is the power of x, 2 x to the power 2 minus 1 is 1. So okay, so we can simplify it. We can write 3 times 5 times 2, how much? This is 30, right? So 30x, right? Then we can write inverse sine of 5x squared all to the power 2 divided by square root of 1 minus 25x squared, and this is our final answer. Example 6. Okay, for example 6, our function f of x is equal to 2 times inverse hyperbolic cot of 5x squared. So 5x squared, right? So here I can according to the constant multiple rule, I can write derivative of this function dx of f of x. Here 2 is a constant, right? So I can figure it out and I can write dx of inverse hyperbolic cot of 5x squared, right? So we'll be talking about this part, right? This is a constant, we don't need to talk about this. So here our inner function is 5x squared, right? And our outer function, which is the original function, is equal to inverse hyperbolic cot of 5x squared, right? So derivative of this function, I can write dx of f of x is actually 2. I can write 2 first, this is constant multiple, then I can take the derivative of the function. Okay, so the derivative of the outer function inverse hyperbolic cot of x is actually minus 1 divided by x squared. So here we have 5x squared, So 5x square all to the power 2 minus 1. So this is the derivative of inverse hyperbolic cot of x, right? So then we need to differentiate the inner function, which is 5 times 2, and this is the power of x, then x to the power 2 minus 1 is actually 1, right? So this is the derivative of this function. So we can simplify this. 2 times 5 10, 10 times 2 is 20, so we can write 20x, right? Then in the denominator we can write 25 x to the power 2 times 2 is 4 minus 1. So this is the answer for this question. Example 7. So for example 7, we have a function which is f of x is equal to inverse hyperbolic cos of 4x squared all to the power 2. So our inner function, which is the base of the function, which is f of g of x is equal to inverse hyperbolic cos of 4x squared, and the inner function, which is f of x is equal to the original function. This is inverse hyperbolic cos of 4x squared all to the power 2. Okay, so derivative of this function f of x is equal to, first we need to apply the power rule, because in our outside function we have a power. So 2 times inverse hyperbolic cos of 4x squared, okay, leaving the inside function as it is. Then derivative of the inner function c. In the inner function we have to apply the chain rule again, because this is our inner function and this is our outer function, right? So derivative of the outer function, okay, which is inverse hyperbolic cos of x is equal to 1 over x to the power x square minus 1. So here our x is 4x square, so x square minus 1, right? And then we need to differentiate the outer function, inner function, which is 4x square, so which should be 4 times 2, 8x to the power 2 minus 1 is actually 1, so we don't need to write it. Okay, the final answer would be 2 times 8, so 2 times 8 what? 16 16x into inverse hyperbolic cos of 4x squared, and in the denominator we have 4 times 4 to the power 2, this is 16 x to the power 2 times 2, 4 minus 1. So this is the answer for this question. Example 8. For example 8, our function f of x is equal to x squared times inverse hyperbolic sine of 2x. Okay, so here we need to apply our product rule. See how. So let u is equal to x squared, right, and b is equal to inverse hyperbolic sine of 2x, right? So in this case our inner function is 2x, and our outer function, which is the original function, is equal to inverse hyperbolic sine of 2x, right? So derivative of b with respect to x would be 1 over derivative of inverse hyperbolic sine of x is actually 1 over square root of 1 plus 2x. So I can write 1 plus x squared, so we have 2x, so 2x squared. Then we need to differentiate the inside function, which is 2x, so answer will be only 2. So final answer will be 2 over square root of 1 plus 4x squared. Okay, so now we have du, and we need to take d also, so du dx is equal to 2x, right? So now according to the product rule I can write d dx of let's say ub, right? It would be u prime b plus u b prime, right? So what is u? U is u prime. So our u prime is 2 over square root of 1 plus 4x squared, right? Then we have our b, which is inverse sine of 2x, right? Then we have our u, which is x squared, and then our b prime. So what is b prime? Our b prime, sorry. So according to the product rule, I can write derivative of ub is equal to u prime b plus ub prime, right? So according to this rule, I can write u prime. What is u prime? U prime is 2x times b. What is b? Inverse sine of 2x, right? Then our u, what is u? U is x squared, and then b prime is 2 over 1 plus 4x squared, right? So final answer would be, yeah, we don't need to simplify it again. So this is fine. Example 9. So example 9, for example 9, we have a function which f of x is equal to inverse hyperbolic sec of 1 minus x squared all to the power half. Okay, so our angle is this one. So this is in a function g of x is equal to 1 minus x squared all to the power half, and f of x, which is the original function or outer function, is equal to inverse hyperbolic sec of 1 minus x squared all to the power half. Okay, so derivative of f of x is equal to, first we need to apply the differentiate the outer function, and according to the inverse hyperbolic differentiation rule, this would be minus 1 over first x. So our x is 1 minus x squared, right, all to the power half, and then square root of 1 minus x squared. So this x would be 1 minus x squared all to the power half, and then this square, right? And then we need to differentiate the outside function. So inside function, this would be, we need to apply the power, right? Half 1 over 2 see, again we have one inside function. So first we need to differentiate the outer function. So half, leaving the inside function as it is, 1 minus x squared, right? And then derivative of the inside function, it would be derivative of 1, half minus 1, right? And derivative of this inside function, which is 1 minus x squared, derivative of 1 is 0, derivative of minus x squared is equal to minus 2x, right? So we need to simplify this, right? So we can write it minus 2 and minus 1. This would be plus 2x, plus 2, and then we can write x, right? And in the denominator we have 1 minus x squared half. Okay, so here see one thing, half minus 1, so actually it would be negative half. So this is in the numerator. If we take it in the numerator, it would be the same thing, 1 plus x squared all to the power half, right? And we have 2 here, so we can write this 2 here, no problem. We can write it here, and then in the denominator we have square root, so we need to write this, and it will be 1 minus these 2 and these 2 get cancelled, so we can write only 1 minus x squared, right? So final answer would be C. These 2 and these 2 gets cancelled, and in the numerator we have only x, and in the denominator we have C. Here our base are same, so we can add the power 1 minus x squared all to the power half plus half, so it would be 1. So I don't need to write 1, and then square root of 1 minus 1 minus x squared. So this is our, yeah, we can simplify it a little further. So just uh, one or two lines. So I can write x over 1 minus x squared, then I can write it, see, this 1 minus 1 minus x squared, so we can write x over 1 minus x squared, and this one gets cancelled. So square root of x squared is actually only x, right? So this x gets cancelled, and the final answer would be 1 over 1 minus x squared. So this is our final answer for this question. It is time to test yourself in finding the derivatives for the given functions. Please pause your video and try to find answers by yourself using what you learned so far, and check your works with mine after you finished. Also, don't forget to watch my solving, where you may broaden your understanding of differentiation through my explanation. So, questions, this question part. Okay, so question 1. For question 1, for question 1, we have a function f of x is equal to ln of 4x squared times minus x to the power 3 minus 4. So clearly it can be seen that this is one function, this is another function, right? This logarithmic function, this is exponential function. So we can take u ln of 4x squared as u, so ln of 4x squared, this is u, and our b is equal to minus x cubed minus 4, right? So derivative of u with respect to x would be, see, we need to apply the chain rule here because this is a composite function. So in place of derivative of ln of x is actually 1 over x. So in place of x we have 4x squared, and derivative of the inner function, which is 4x squared, would be 4 into 2 is the power, and this is the constant multiple, 2x to the power 2 minus 1 is actually 1. So, and this gets cancelled, so we can write 2x over x squared, right? Then we have a common multiple, which is x on in numerator and denominator, so we can write 2 over x. This is the derivative of u, right? And derivative of b with respect to x would be minus 3x, 3 minus 2 is actually 3 minus 1 is actually 2, and negative minus derivative of 4 is 0. So according to the quotient rule, I can write ub. So ddx of ub is actually u prime b plus ub prime, right? So what is u prime? U prime is actually 2 over x, right? And then b is actually minus x cubed minus 4 plus, what is u? U is ln of 4x squared, and then we have b prime, so which is 0, right? So we can write minus 2x cubed minus 4 times 2 is 8 divided by x. So this is our final answer for this question. So question 1. For question 1, we have a function f of x, which is ln of 4x squared times minus x to the power 3 minus 4. So if you check it carefully, you can see, easily understand that this is one function, this is another function, and they are multiplied together. So we can use product rule. So let u is equal to ln of 4x squared. So derivative of u with respect to x would be, this is a composite function, so this is inner function. So we can write 1 over ln of x, derivative of ln of x is equal to 1 over x. So in place of x we have 4x squared, then we need to differentiate the inner function, which is 4x squared. It would be 4 times 2x to the power 2 minus 1 is 1, right? So final answer would be 2x divided by x squared. We have a common multiple, which is x, so we can write 2 over x. then derivative then b is equal to minus x cubed minus 4, right? So derivative of b with respect to x would be minus 3x 3 minus 1 is actually 2. Derivative of 4, which is a constant, is 0. Okay, so now we can apply the product rule. So dx of u b is equal to u prime b plus u b prime, right? So what is u prime? U prime is 2 over x, right? And then b is equal to minus x cubed minus 4 plus u is equal to ln of 4x squared, and then our b prime is minus 3x squared, right? Then we can write minus 2x cubed minus 4 times 2 is actually 8. So we can write this over x plus, right? So actually this minus times plus is minus, right? So minus 3x squared ln of 4x squared, right? So we can keep it, we can leave it here, or we can simplify it a little bit. So x, so the answer would be minus 2x cubed minus 8 minus, and yeah, this would be 3x cubed ln of 4x squared, right? So this is the answer for this question. Question 2. For question 2, we have a function which is f of x is equal to 4x to the power 4x, right? Okay, so we can apply the constant multiple rule here. So d dx of f of x is equal to 4 times d dx of x to the power 4x, right? Okay, so how can we differentiate this x to the power 4x? Normally for exponential function, in power we have only one power, but here we have variables also. So how we can differentiate this? Question 2. So for question 2, we have a function which is f of x is equal to 4x to the power 4x, right? So we have two functions, one constant function, one exponential function. So we can take, let u equal to 4 and derivative of du with respect to x is 0. Okay, then we have b, which is x to the power 4x, right? And if we apply ln, because we cannot differentiate it easily, so what we can do, we need to apply ln on both sides. So ln of b is equal to ln of x to the power 4x, right? So if we differentiate both sides, then it would be d dx of ln of b is equal to yeah, before we can do one thing on this side. So according to the logarithmic rule, we can write 4x of ln of ln of x, right? We can write this. So now we can take the derivative of this function, d dx of 4x ln of x, right? So on the both side we need to take the, we need to apply the chain rule, because both functions are composite function, right? So we have one inner function, one outer function. This, yeah, on this side, on the right side, we need to apply product rule, because we have one function, we have another function. So what we can do on the left side, so derivative of ln of b is actually 1 over b, and this is b is not we need to take the derivative again. So db by dx, right? So actually ln of x is actually 1 over x. Yeah, so here x is not x is b, so we need to take derivative of b again. So I have taken this all. So is equal to, we need to apply the power rule, sorry, the product rule. So according to the product rule, first we need to take the derivative of u. So let's say our u is 4x, so derivative of 4x would be only 4, and derivative then we need to write the b. So what is b? Ln of x, right? Then plus, now we need to write our use of 4x, and then derivative of b, which is 1 over x. So this x and this x gets cancelled, so I can write 4 ln of x plus 4, right? And on the denominator, like on the left side, we have 1 over b times db by dx. I can write simply b prime only, right? They are the same thing. So b prime is equal to, if we multiply both sides by b, then we can write on the right side b times 4 ln of x plus 4. We can simplify it a little further. We can take 4 as a common multiple and write 4b of ln of x plus 1, right? So this is our b prime. Now we can take the derivative of our original function. So d dx of 4x to the power 4x. Okay, so here we can apply the product rule. So derivative of 4 is 0 multiplied with the b, which is, we don't need to write it, I'm just writing it. Okay, then plus u. So u is what? 4, right? And what is b prime? So b prime is this long thing. So 4b into ln of x plus 1, right? So we can write d dx of 4x to the power 4x is equal to 0 plus 4 times 4 is actually 16v first bracket ln of x plus 1, right? So final answer would be 16. We need to substitute the value of value of v, which was x to the power 4x, right? X to the power 4x, then we need to multiply with ln of x plus 1. So this is our final answer. Or we can write one more line. So 16x to the power 4x times ln of x plus 1. So this is the final answer for this question. Question 3. So for question 3, we have a function which is a very long function, ln of minus 4x to the power 4 divided by x to the power 3 minus 3 all to the power 5. So if you check one thing here, so this is our inner function. So our g of x would be minus 4x to the power 4 divided by x to the power 3 minus 3, right? Question 3. So for question 3, we have a function which is equal to 4 to the power 4 x question 3. So for question 3, we have a function which is f of x is equal to 4 to the power 4x to the power 4, right? Okay, so to solve this kind of problem, we need to use one formula. You will find it in the formula sheet, but I am writing it here again. So it would be d dx of a to the power u is equal to a to the power u times u prime. Here is derivative of u ln of a. So we need to apply this formula. So derivative of this function d dx of 4 to the power 4x to the power 4, it would be equal to, first you need to write the function as it is, 4 to the power 4x to the power 4, right? Then the derivative of this power, which is 4 times 4x to the power 4 minus 1 is actually 3, and then ln of a. So ln of a, what is a? Here a is 4. So this is our final answer for this question. Okay, and question 4. Okay, so for question 4, we have a function which is f of x is equal to log base 3 of 3x squared. So even to solve this kind of problem, we need to use one more formula. This would be derivative of derivative of, yeah, log base a of u is equal to u prime, means derivative of u times ln of a. We need to use this formula. So derivative of this function f of x is equal to first u prime. So what is u here? This term, right? So it would be 3 times 2x to the power 2 minus 1 is actually 1, right? Then u, what is 3? What is u? 3x squared, right? Times ln of a. What is a? A is 3. So we can rewrite it again. Okay, this 3 times 3 gets cancelled. So we can write 2x over x squared of ln of 3. Even we can simplify it a little further. So we have one common multiple which is x. So we can cut x from denominator and from the numerator. So it would be 2 divided by x ln of 3. So this is the answer for this question. Question 4. So for question 4 we have a function f of x is equal to log base 5 of tangent of 4x to the power 4, right? So see, this is also a composite function. So question 5. So question 5, for question 5 we have a function which is f of x is equal to log base 5 of tangent of 4x to the power 4, right? So derivative of this function, first see this part. Okay, so this is a composite function. So for, okay, let me write it here, 10 of 4x to the power 4. Okay, so derivative of this function would be ddx of this function would be this is our, so for this inner function d of x is equal to 4x to the power 4, right? And outer function, which is the original function, is equal to 10 of 4x to the power 4, right? So first we need to take the derivative of the outer function. So derivative of 10x is actually sec square of x, which is here it is 4x to the power 4, and then derivative of the inner function, which is 4 times 4x to the power 4 minus 1 is 3, right? Okay, this is the derivative of the of 10 of 4x to the power 4. So now we can take the derivative of the original function d dx of f of x is equal to, first we need to take the, according to the rule, we can write first u prime, right? So the whole thing was u, this whole thing was u. So derivative of u is actually this 4 times 4, I can rewrite this again. So 4 times 4, 16 x to the power 3 sec square of 4x to the power 4, right? So this is u prime, right? So I can write 16x cubed sec of 4x to the power 4 or to the power 2 divided by, what we need to write? So first u, what was u? This was 10 4x to the power 4, right? Then we need to write ln of a. What was the a? This was 5. So this is the answer for this question. and yeah, everything is fine. So this is the answer. Question 6. For question 6, our function f of x is equal to ln of 2x to the power 4. So this is the inner function. So g of x is equal to ln of 2x to the power 4. So for this case, this is the inner function, right? Sorry. So this is the inner function for this case. So derivative of g of x would be first derivative of the outer function. So this is the outer function, right? So 1 over x, which is 2x to the power 4, right, times inner function, derivative of the inner function, which would be 2 into 4x to the power 4 minus 1 is 3. Okay, so these two get cancelled. Here we have x to the power 3. So from the denominator and the numerator, x3 gets cancelled. So we are left with only 4 over x, right? We are left with only 4 over x. So now we can find the derivative of f of x. So first we need to take the derivative of, and f of x is equal to ln of 2x to the power 4. So derivative of this function, ln of x is actually 1 over x. So in place of x we have this much. So ln of 2x to the power 4, right? And derivative of the inside function. So derivative of inside function, we have taken it only 4 over x. The final answer would be 4 over x ln of 2x to the power 4. So this is the final answer for this question. This is the last question to check your understanding of the rules of differentiation. So this is our last question, question 7 I think. So f of x is equal to, the function is e to the power 4x to the power 3 plus 5 all to the power 2. Okay, so according to the rule of this function, d dx of e to the power u is actually e to the power u times u prime ln of a, right? So according to the rule, I can write derivative of d f of x is equal to, first we need to write the function as it is, 4x to the power 3 plus 5 all to the power 2. Then we need to take the derivative of this function, right? So derivative of this term would be, we need to apply the power rule, right? So 2 into the base 4x cubed plus 5, and now we need to apply the we need to take the derivative of the inner function, which would be 4 times 3x, 3 minus 1 is equal to 2, right? Then derivative of 5 is 0. Okay, then we need to multiply this whole thing by ln of e, right? So final answer would be e to the power 4x cubed plus 5 all to the power 2 times 2, 4x cubed plus 5 squared 4 times 3. This will be 24. This will be 12, right? 4 times 3 12x squared. Okay, so final answer can be 12 times 2 24. So 24x squared into 4x cubed plus 5 into e to the power 4x cubed plus 5 all to the power 2. So this is the answer for this question. So through this question we have finished our integration part, and later we'll start our integration. In this part of our course we'll be talking about integration, and firstly we'll go through the general rules of integration, and for each rule we'll be solving a number of problems, and after doing this we'll go for two special techniques of integration, which is called integration by parts and integration by substitution. And after doing this we'll be checking our ability or understanding through some random problems. So let's start with integration. So first rule of integration, which is called constant rule. So general format of constant rule. So let's say first we have a function f of x is equal to c. So this c is any constant. Okay, so integral of this function f of x is c times x plus c. This c is any arbitrary constant. Be careful with this c. This c and this c are same, but this c is a different c. I'll explain it later. So we can solve some problems for this rule. Okay, so example 1, let's say we have a function f of x is equal to 5. Okay, then integral of this function, or we can write it integral of 5 dx is equal to 5 times x plus c. Example 2, for example 2 we have a function, this is also a constant function, right? So let's say this is pi, so integral of this function is equal to pi times x plus c. And example 3, for example 3 we can choose a function, let's say e to the power 5, right? So see, e is a number and this power is also a number, so ultimately we are getting a number. So integral of e to the power 5 dx is equal to e to the power 5 x plus c. Earlier I told you that I'll explain why we add c in the process of integration. Okay, so to understand it, let's consider we have a function f of x is equal to x square plus 5, and we have another function f of x is equal to only x square. Okay, so derivative of this function ddx of x square plus 5 is equal to 2 5 only, and derivative of this function ddx of x square is also 2x square. So from the same function we are getting the same derivative function. This function is called derivative function. Okay, so if you take the integral of this derivative function 2x dx, it would be 2 into x to the power 1 plus 1 over 1 plus 1. So finally it would be x squared, and here also the same thing, 2 into x to the power 1 plus 1 divided by 1 plus 1. So final answer would be x squared. Okay, so you know integration is an inverse process of differentiation. So this is the integral function. Here we are getting only x square, but our original function was x square plus 5, and here we are getting x square, even our original function was x square. But from this derivative function we are not getting our after doing the integration we are not getting our original function, which was this x square plus 5. So to integrate that, maybe there was a constraint. To just integrate this, we always add a c in both cases. For any any integration we need to add this c. indicates that maybe there was a constant in the original function, but this c can be 0. See, for this case this c is 5, right? But for this case this c is 0. Okay, so to find out this c, if you study further calculus in differential equation, here we have a topic. This is called initial value problems. So in initial value problem, through the given equation and some initial value, you can find out this c. But here in this stage, it is not possible to find out this c. Let's talk about the second rule of integration, which is called power rule. So let's say our function f of x is equal to x to the power n. So integral of this function is equal to x to the power n plus 1. This is the power, right? N is the power, so n plus 1. And here is one important thing. This n cannot be negative 1. Okay, so this is the condition of power rule. So let's do some examples. So example 1, our function for example 1 is x to the power 5. So integral of this function x to the power 5 is equal to x to the power 5 plus 1 divided by 5 plus 1, and we need to add this c, right? So the answer would be x to the power 6 divided by 6 plus c. Example 2, and for this our function is square root of x. So integral of this function, we can write it in different ways. X to the power half dx is equal to x to the power half plus 1 divided by half plus 1 plus c. So the answer would be x to the power 3 over 2 plus c. So final answer would be 2 over 3 square root of x to the power 3 plus c. We can solve one more example. Example 3. So for this example 3, our function, given function is x to the power negative 1 over 4. So integral of this function x to the power negative 1 over 4 is equal to x to the power negative 1 over 4 plus 1 divided by 1 over 4 plus 1 is equal to plus c is equal to x to the power minus 1 plus 4 divided by minus 1 plus 4 divided by 4 plus c. So final answer would be 4 over 3 fourth root of x cubed plus c. So this is the answer for this problem. Let's talk about constant multiple rule. Constant multiple rule. So the general format for this constant multiple rule is, let's first write the general function for constant multiple rule. This would be f of x is equal to cy. This y is any function, any differentiable function. So integral of this function, here this c is a constant, any constant. So integral of this function or cy is equal to, first we can factor out this constancy from the integration. So we can write c integral of y dx. Okay, so let's do some example on this rule. So example 1, a function for example 1 is 6x. So integral of this function 6x is equal to 6x. When we don't have any power, it means we have a power which is 1. We don't write this power, so 1 plus 1 and 1 plus 1. okay, plus c, then the answer would be 6x to the power 2 divided by 2 plus c. So final answer would be 2 goes into 6 3 times, so 3x to the power 2 plus c. Example 2. Our function for example 2, f of x is equal to 3x to the power 5. Okay, so integral of this function 3x to the power 5 is equal to, we can write it in a different way according to the constant multiple rule. So 3, first we are factoring out this 3 from the integration process. So 3 into x to the power 5 dx. So now we can do the integrations. 3, so we have a power 5, so 5 plus 1 divided by 5 plus 1, okay, and now we are adding this c. We do need to add this c at the end of the integration, so don't write it before this, okay. Maybe you are wondering, I'm not multiplying this 3 with this c. You don't need to multiply this 3 with this c, because if you multiply this 3, then we will get another constant, and we don't know this constant. That's why keep it as it is. You don't need to multiply this. Is equal to 3 x to the power c divided by, sorry, x to the power 6 divided by 6 plus c. 3 goes into 6 2 times, so final answer would be x to the power c half times x to the power c. So this is the answer for this question. Example 3. For example 3, we have a function f of x equal to 5 times cos of x. So integral of this function 5 times cos of x is equal to, we can rewrite it again, 5 times integral of cos of x dx. So 5, we can put a bracket to separate it from the integration. Okay, so in integral of cos of x is actually sine of x, right? So sine of x, so please check the formula sheet, it is given. So, and then we can put our c, what we need to put in case of integration. So final answer would be 5 sine of x plus c. Now we can take about two other rules of integration, which are called sum and difference rules. So sum and difference rules. So according to the sum rule, we can write, I'm just writing the formula. So let's say we have a function, we have two functions, f of x and g of x. So integral of these two functions together would be integral of f of x plus g of x, and put two brackets and then dx. This would be integral of f of x dx plus integral of g of x, okay. And for a difference rule, it would be integral of f of x minus g of x dx is equal to integral of f of x minus, let's talk about two other rules of integration, which are called sum and difference rule. So sum and difference rules. Okay, so according to this rule, we can write for sum, integral of, let's say we have two functions, f of x and g of x. So integral of these two functions would be f of x plus g of x is equal to integral of f of x plus integral of g of x. And for difference rule, integral of f of x minus g of x is equal to integral of f of x minus integral of g of x. Okay, this is the two rules of integration. So let's do some examples. Example 1. For example 1, we have a function y which is equal to 6x square plus pi. Okay, integral of this function 6x square plus pi is equal to integral of 6x square dx plus pi integral of pi dx. Okay, we can rewrite it. We can factor out this c from the integration. Okay, so this is our constant according to the constant multiple rule, and we can write it like integral of x square dx plus, we can factor out this pi also, so pi integral of dx, right? So we can write it again 6. We can put a bracket to separate it from the integration. So x square, we have a power 2 which is 2, so 2 plus we can write 2 plus 1 divided by 2 plus 1. Then we can write this pi, and we are integrating here, we are integrating pi, right? So the answer would be pi into x, right? We are integrating with respect to x, so we need to put this x. We are integrating any constant, only any constant. The answer initially you so that answer would be this constant into with respect to what we are integrating. So in our case it is x, so we need to write x. So the answer would be pi x, right? So finally we can add our c. So we can simplify it a little further. We can write, see, in the denominator we have 3, right? And here we have 6. So this 3 goes into 6 2 times. So we can write 2 x to the power 3 plus pi x plus c. You will be wondering, see, we have done integration 2 times here. Okay, so here is 1 time, here is 1 time. So we are supposed to get 2c, right? But actually c, if we add 2c, we don't know this c, this is the main thing. And later if we add this 2c, we will get another c. It's c means constant. So for this reason, for any integration, whether we don't need to consider how much terms we have in a function, we don't need to consider this. For any integration we need to put only one constant. So keep it in mind. Maybe some cases you will be confused. So you don't need to do anything with this constant. Just do your integration, and at the end just put this c. So you are done with the process. You don't need to add it multiple times, or you don't need to multiply it with any other number or anything. So let's do example 2. So our function y is equal to 7x minus x cubed. Okay, so integral of this function 7x minus x cubed dx, we can rewrite it integral of 7x dx minus integral of x cubed dx, right? We can factor out this constant. Okay, 7 integral of x dx minus integral of x cubed dx, and then we can write, so 7, and then we can put a bracket. So integral of x is actually x to the power, we don't have any power here, so we can imagine we have 1. Actually we have we have a power which is 1, so we don't write it normally. So 1 plus, according to the this power rule, we need to add 1, so divided by 1 plus 1. Okay, so then minus x to the power, we have a 3, so 3 plus 1 divided by 3 plus 1, and then add a c. Okay, then we can simplify it a little further. We can write this c, 1 plus 1, we have 2, so 7 divided by 2 x to the power 2 Then we have x to the power 3 plus 1 is equal to 4 divided by 4, then plus c. So this is the answer for this question. Example 3. So for example 3, our function y is equal to 5 to the power x plus 1 over x. Okay, so we can take the integral of this function, integral of 5 to the power x plus 1 over x, and we can rewrite it again, integral of 5 to the power x dx plus integral of 1 over x dx, right? So here I need to mention one thing. Please check the formula sheet. You will find integral of a to the power x dx is actually a to the power x ln of a plus c. Okay, and integral of 1 over x is equal to, we can rewrite it again, x to the power negative 1, right? The same thing. We cannot apply power rule here, because in the power rule I told you that this power which is here 1, this cannot be negative 1, so we need to apply another rule, and according to this rule, integral of 1 over x is actually ln of x. So we need to apply these two rule of integration. Sometimes I will mention this kind of rules, but always check the formula sheet, please. So we can rewrite it again. So integral of, okay, so according to this formula we can apply this formula here, right? So we can write 5 to the power x over ln of 5, because our a is 5, right? And now we don't need to put this c, we'll put it at the end. So plus, and integral of 1 over x is equal to ln of x. So now it is time to put c. So I told you, for any kind of integration, just put c at the end. Don't put, like, for all your expression, just put only one c. Okay, so this is the answer for this question. We may do one more example on this rule. So let's say our example 4. So function is y is equal to e to the power 5x plus 5x square. Okay, so integral of this function e to the power 5x plus 5x squared is equal to, we can write it, integral of e to the power 5x, e to the power 5x dx plus, we can factor out this 5 from the integration. Okay, so we can write 5 into integral of x squared dx, right? So these are the same thing. So here we have one special function, e to the power 5x. So you will find this formula in the formula sheet, but I am writing it here. E to the power ax dx is equal to e to the power ax divided by a, then plus c. Okay, so according to this formula we can take the integral of e to the power 5x. So e to the power 5x divided by, here our a is 5, okay, then 5 plus 5 into x, we have a power 2, so 2 plus 1 divided by 2 plus 1. Okay, so 2 plus 1, and then finally we can put a c. Okay, so our answer would be e to the power 5x divided by 5 plus 5 divided by 3 x to the power 3 plus c. So this is the answer. Why we are not integrating one algebraic formula? Let's do one example on this. So example 5, a function y is equal to one algebraic formula or identity x plus 2 whole to the power 2. Okay, so we can expand this x square plus 2x2 plus 2 square, which is x square plus 4x plus 4. So we integral of this function x square plus 4x plus 4 is equal to x squared dx plus, we can factor out this 4. So integral of x dx plus 4 integral of dx. So here you consider we have 1. Okay, so integral of x squared is actually x to the power 2 plus 1, which is 3. Sorry, which is 3 divided by 3 plus 4 into, so here our power is 1, so 1 plus 1 is actually 2 divided by 2. So this 2 goes into this 4 is 2 times. Okay, 2 times plus 4x, because we are integrating 4, and the integral of any constant is this constant into with respect to which we are integrating. So with respect to x we are integrating, so 4x. Okay, so final answer would be 1 over 3x cubed plus 2x squared plus 4x. Now I'll talk about one of the important techniques of integration, which is called integration by substitution. So integration by substitution. So to understand this technique, we need to solve a number of problems. So let's start with problem or example number 1. So example 1. For example 1, we have a function f of x is equal to minus 15x to the power 4 into minus 3x to the power 5 minus 1 all to the power 5. Okay, so integral of this function minus 15x to the power 4 is 3x to the power 5 1 to the power 5 dx. Now our task is to select our u. So we need to select u such a way so that through u and du we can represent this whole integral function. So let u is equal to minus 3x to the power 5 minus 1, and therefore du dx is equal to minus 3 into 5 15x to the power 5 minus 1 4. Okay, so du is equal to minus 15x to the power 4 dx. Okay, so if you check this du minus 15x to the power 4 dx, see here we have minus 15x square, here we have dx, and if you check u we have this thing. Okay, so this part is u, so we can rewrite this function simply. So integral of u du. Okay, but here see our u is only negative 3x to the power 5 minus 1, so we have a power here, so this power is 5. So integral of u to the power 5 du is equal to, according to the power rule, u to the power 5 plus 1 is equal to c, 6 over 6 plus c. So we can substitute our value for u, which is minus 3x to the power 5 minus 1 all to the power 6 divided by 6 plus. So this is the final answer for this example. Example 2. So for example 2, we have a function f of x equal to minus 8x to the power 3 over minus 2x to the power 4 plus 5 all to the power 5. So integral of this function minus 8x to the power 3 over minus 2x to the power 4 plus 5 all to the power 5 dx. Okay, so now we need to choose our u. So let u is equal to minus 2x to the power 4 plus 5. So derivative of u with respect to x would be minus 2 times 4, 8, x to the power 4 minus 1 is 3. Therefore du is equal to minus 8 x to the power 3 dx. So now we have u, we have our du. Now we can relate our integral function. Okay, so integral of, see this part is du. Okay, so I can write du over, this is our u, right? So u, but we have a power here again, so this power is 5, so I can write this function again, integral of 1 over e to the power 5 du, and this function is in the denominator, so if we put it in the numerator, then I need to write in this way, u to the power minus 5. I believe that you know this thing. Okay, so the now we can apply power rule of integration. So e to the power minus 5 plus 1 divided by minus 5 plus 1 plus c is equal to the we can substitute the value of u. So what is u? So u is equal to minus 2x to the power 4, right, plus 5 all to the power minus 5 plus 1 is equal to 4 divided by 4 plus c. So this is the answer for this example. Sorry, I forgot to put this negative sign. Here we have a negative sign. So if we want to rewrite it again, we can write it in this way: minus 2 times x to the power 4 plus 5 all to the power 4 divided by 4 plus c. Example 3. So we have a function for example 3. F of x is x equal to 5x to the power 4 plus 5 all to the power 2 over 3 into 20x to the power 3. So integral of this function 5x to the power 4 plus 5 all to the power 2 over 3 times 20 times x to the power 3. Okay, now we need to choose our u. So let u is equal to 5x to the power 4 plus 5, right? So derivative of u with respect to x would be 5 times 4, 20, 4 minus 1 is 3. So du is equal to 20x to the power 3 dx. So if you check now, we have du which is 20x to the power 3 dx, we have it here, and our u is 5x to the power of plus 5, we have it here. So we can rewrite our integral function. So integral of, okay, so integral of u, we have a power which is 2 over 3 and then du. Okay, so we can apply our power rule of integration to integrate this. So u to the power 2 over 3 plus 1 divided by 2 over 3 plus 1 plus c. So now we can substitute the value of u, 5x to the power 4 plus 5, right, to the power 3, and 2 plus 3 is equal to 5 divided by 5 over 3 and plus c. So we can write it simply 3 over 5, right, and then cube root of 5x to the power 4 plus 5 all to the power 5. Example 4. So for example 4, we have a function f of x is equal to 4 sec of 4x times 10 of 4x times sec of 4x all to the power 4. Okay, so integral of this function 4 sec of 4x times 10 of 4x times sec of 4x all to the power 4, right, all to the power 4 dx. Okay, dx. Now we need to choose our u. We need to be very careful this kind of problems. We need to make sure that our by u and du you can represent this whole function. So let u is equal to sec of 4x. You know, derivative of u with respect to x, like derivative of sec of x is actually yeah, let me explain what something is. This is very important here. Okay, see, here is one thing. We have an angle which is not only x, which is 4x. So this is our initial, like our inner function g of x is equal to 4x, right? And our outer function is the original function which is sec of 4x. So we need to apply chain rule here. This is a composite function, right? So du dx is equal to, first we need to differentiate the outer function. So derivative of sec x is actually sec of x, which is here 4x, sec of x times 10 of x, which is 4x. Okay, so we are done with the derivative of outer function. Now we need to differentiate the inner function. So derivative of 4x is actually only 4. So we can write du is equal to sec of 4x times 10 of 4x. Okay, we can put our 4 in front of all and dx. So if you check now, you will see, so this we have our du is equal to this much. Okay, so we have this here 4 sec of 4x and then 10 of 4x, then this is dx. Okay, and our u is this much, right? So we can rewrite our integral function, integral of du. Okay, du, then before this we can write u, but here we have a power which is 4. Here I need to mention one thing, simply this is a note. Okay, so sec of 4x all to the power 4, we can rewrite it like this, sec of 4x all to the power 4. This is the same thing, so that is why I am putting 4 on u. So we need to apply power rule of integration here. So u to the power 4 plus 1 is equal to 5 divided by 5 plus c. And if you substitute the value of u, which is sec of 4x, okay, to the power 5 divided by 5 plus c. So this is the answer of this example, or you can rewrite it again, sec of 4x, you can put the power here, okay, then divided by 5 plus c. Example 5. So for example 5, our function f of x is equal to 5 plus ln of x all to the power 5 over x. Okay, so integral of this function, integral of 5 plus ln of x all to the power 5 divided by x dx. Now we need to choose our u, so be careful with this. Let u is equal to 5 plus ln of x. So see here, yeah, this is okay. So derivative of u with respect to x is derivative of 5, this is a constant 0, and derivative of ln x, derivative of ln x is actually 1 over x, right? So du is equal to 1 over x dx, right? So 1 over x dx. So now we have du, we have u, and we can rewrite our integral function. So integral of, so 1 over x, right? So du is equal to, so first we can write our u, so u to the power 5, and right, so u to the power 5 so okay, u to the power 5 divided by, so you know our du is equal to 1 over x du and dx, right? So this part, so this part is equal to du, right? So du, okay, then I can write it again according to the power rule of integration, u to the power 6, 5 plus 1 6 plus c. So if you substitute the value of u, then you will get 5 plus ln of x all to the power 6 divided by 6 plus c. Example 6. For example 6, we have a function f of x is equal to 80x to the power 3 times 3 to the power 5x to the power 4 minus 2. Okay, so this is our function. So integral of this function 80x to the power 3 times 3 to the power 5 x to the power 4 minus 2 So now we need to choose our u. Okay, so let u is equal to this power 5 x to the power 4 minus 2. Okay, so derivative of this u d, okay, with respect to x is equal to 5 times 4, 20 x to the power 4 minus 1 is 3. So du is equal to 20 x to the power 3, then dx. Okay, so here you need to check one thing. See, we are getting this 20, but here we have 80. So we need to divide this 80 by 20. So if you divide it by 20, what you will get? We will get 4. This is the, okay, this is the answer of the division. So we can rewrite it again without putting the values of u and d, without substitution of u and d. So rewrite this integral version again. So integral of 4 times 20 x to the power 3 times 3 to the power 5 x to the power 4 negative minus 2 dx. Okay, so now we can simply write. So we have 4, then this term, these two terms is equal to du, right? So du, and in between we have a 3, and 3 to the power our u, so u, right? Okay, so we can factor out this constant multiple 4, integral of 3 to the power u du. Okay, so we can write again 4 into, according to the formula, if you check the formula, this should be 3 to the power u ln a. So here a is 3, okay, then plus c, and if you substitute our value of u, then it would be 4 3 to the power u. What is u? U is equal to 5 x to the power 4 minus 2 divided by ln of 3 plus c. So this is the answer for this question. Example 7. Function for this example is 12x to the power 2 divided by x cubed plus 2. So integral of this function 12x squared divided by x cubed plus 2 dx. Okay, so let u is equal to x cubed plus 2. So derivative of this function is 3x to the power 3 minus 1 is equal to 2. Therefore du is equal to 3x squared dx. But see, check it very carefully. Here we have 3, but we have a number which is 12. Okay, so we need to adjust it anyway, right? So we need to divide it. 12 divided by 3 is 4. So we need to multiply it with 4. So 4 into 3 x squared divided by x cubed plus 2 dx. This is the differential. Okay, this dx. So if you substitute the value of like if you substitute u and du, then it would be so 4 times du, right? Du, because 3x squared dx is our du divided by our u, right? So we can rewrite it again simply factoring all these 4. So 4 integral of 1 over u du. Okay, so I can write it again. So sorry, let me remove this. Okay, 4 into, then 1 over u, integral of 1 over u or 1 over x is actually ln of x, or here we have ln of u, right? Ln of u, then just put a c. So if you substitute the value of u, it would be ln of x to the power 3 plus 2, then we have a c, right? So this is the answer for the question. Example 8. For example 8, our function is minus 5 times cos of minus 4 plus ln of 4x. Okay, and it is divided by x. So integral of this big function 5 times cos of minus 4 plus ln of 4x divided by x, and here we have dx. Okay, so let u is equal to this the base of this exponential function, which is minus 4 plus ln of 4x, right? So here you need to understand one thing. um, for this we have in a function in a function g of x is equal to 4x, because it is not only x, it is 4x. So we have in a function 4x, and outer function, which is f of x, is equal to ln of 4x. So we need to differentiate this u. So du dx is equal to derivative of any constant is 0, then 0 plus. Now we need to differentiate the outer function, which is ln of 4x. So it would be 1 over, keep the inner function as it is. This is 4x, right? And then differentiate the inner function, which is only 4. So final answer would be 4 cancel, it would be 1 over x. So now we have, okay, to one more step to find the u. So du is equal to multiply both sides by dx. It would be only 1 over x dx, right? So now we have u, du, everything. So we can rewrite this this integral function again. So it would be, so minus 4x, so it would be, so we can use our u and du. So first factor out this 5. So this is 5 minus 5, this equal to minus 5 integral of, so cos of this angle of cos is actually u. So this is u, then divided by 1 over x 1 over x times dx is equal to du. So we can just write du here. So we can integrate it very easily. 5, and integration of cos is actually sine. So cos of u is actually sine of u. You can write sine of u, right? Then just put a c, then it will be minus 5 sine of u is equal to minus 4 plus ln of 4x plus c. So this is the answer for this question or example. Example 9. For example 9, our function is 4x cubed divided by cosec of x to the power 4 minus 1. Okay, so integral of this function 4x cubed over cosec of x to the power 4 minus 1 dx. Now we need to choose our u. So let u is equal to x to the power 4 minus 1. So du is equal to, du dx is equal to 4x to the power 4 minus 1 is 3. Therefore du is equal to 4x to the power 3 dx. So we can rewrite this, we can rearrange our integral function. So integral of see this whole part is du, right? So this is du, and we have this part is u, right? So u, so actually this is cosec of u, right? This is cosec of u. So how can we cosec of u, 1 over cosec of u is actually sine of u or sine of x, u. Okay, so this is the trigonometric rules, right? So just du, right? Then the integral of sine of x or sine of u is actually minus cos of x. So cos of u plus c. Now substitute the value of u, which is x to the power 4, sorry, x to the power minus x to the power minus 1, right? So minus cos of x to the power minus 1 plus c. So this is the answer for this example. So example 10, this is our last example for this kind of technique. So example 10, function for example 10 is 20x cubed over square root of 25 minus 25x to the power 8, which can be written as 20x cubed, simplify a little bit, 5 squared minus 5x to the power 4 all to the power 2, right? So integral of this function is 20x cubed over 5 squared minus 5x to the power 4 all to the power 2. Okay, we need to put the square root root sign, so dx, right? So let our u is equal to 20x cube. Therefore du dx is equal to 20 into 3, 20 times 3 is equal to 60. X to the power 3 minus 2 is actually 2. So du is equal to 60x squared dx. So we have u, du, everything, right? So we can rearrange our function. Okay, so we can write, so 20x cubed is actually u, right? And c, no, we have 20, right? We have 60, so we need to divide it. So if you divide 60 by 20, then you will get 3. So our function should be divided by 3, right? So divided 1 over 3, and then we can write this du, right? Then we can write du, right? Then in the denominator we have the same thing, 5 squared minus 5x to the power 4 all to the power 2. Okay, so we have a constant here, so we can factor this 1 over 3 square root of 1 over, so 5 squared, first write this root symbol, 5 squared minus 5x to the power 4 all to the power 2, right? And this is du. Okay, so if you check the formula sheet, then you will see this is integral of this function is actually 1 over 3. This is our constant term, and then we have if you check this formula sheet, you will find this should be inverse sign of this. So this actually x, so in place of x we have 5x to the power 4, and then this part which is 5. Okay, so this is our answer. Now we can talk about the other important technique of integration, which is integration by parts. So first write the headline, integration. So integration by parts. So this is integration by parts, and we have a formula for this. Which is integral of u db, which is equal to ub minus integral of b du. So here we need to choose two things. One thing is not given. Yes, here we need to choose these two things. So to choose these two, we have one rule, which is LIATE, right? So what represents what? So let me label them. So L is for logarithmic function, I is for inverse function, inverse function, A is for algebraic function, U is for exponential function. So in this case we need to choose already the first one. Let's say we have one example. In this case we have two functions, one is algebraic and one is logarithmic function. So for u we need to go for logarithmic function, and for algebraic one we need to go for db. Example 1. For example, we have a function which is f of x is equal to x times e to the power x. So integral of this function, integral of x times e to the power x dx. So we have two things. See, this function is called integral. So we have two things here. So one function is algebraic, right? Algebraic, and another one is exponential. So if you check the rule of LIAT, you will definitely see x comes before e to the power x, because e to the power x is an exponential function and x is an algebraic function. Because algebraic comes first, so we need to label x as u. So we can label them like that. U is equal to x. Therefore, we can write du dx is equal to 1. We can direct again like du is equal to dx, right? And db is equal to e to the power x dx, right? So if you divide both sides by dx, we can write db by dx is equal to e to the power x. So now integrate both sides. So we can write db dx is equal to integral of e to the power x dx, and on the left side we are left with only b, because here integration and differentiation, both techniques are going together. That's why they one cut another one, right? So integrate both sides. So integrating both sides, we can write integral of db dx dx is equal to integral of e to the power x dx. Here on the left side we are left with only b, because integration is an inverse process of differentiation. They cancel each other. So b is equal to integral of e to the power x is actually e to the power x only plus c. Okay, so according to the formula, first let me write the formula again. So integral of u db is equal to ub minus integral of b du, right? So according to formula, you can write, sorry, I don't need to write this. Just write what is u. U was x and b was b e to the power x. I don't need to write this c, because if I write c here, and for this b I will need to write plus c here. So finally this part will be positive, negative, because we have a minus sign here and we have a plus sign here. So this c would be the part, because this will not be only c, we need to add something, multiply something with this. X will be multiplied with 6. Okay, so finally these two terms will be same, but with the different sign, with the opposite sign. So they will cancel each other. That's why we don't write them. Okay, just put minus sign, and integral of b, what is b, e to the power x, and d du, right? Yeah, so no, du, what is du? Du is actually dx. So okay, du is equal to dx. That's why I am writing dx. So x e to the power x times e to the power x minus integral of e to the power x is actually e to the power x, right? So finally we can put c. So if you want to like take the common e to the power x, so e to the power x minus 1 plus c. So this is the answer for this example. Example 2. For example 2, we have a function f of x is equal to x times cos of x, right? So integral of this function, integral of cos times, x times cos of x dx. Now this is time to choose our u and x. So if you check, we have two functions here, algebraic function and trigonometric function. So algebraic function comes before trigonometric function. That is why our let u is equal to x, because this is algebraic function. So du dx would be 1. Therefore we can write du is equal to dx, right? And our db is equal to cos of x dx. If you multiply, divide both sides by dx, the equation would be d by db dx is equal to cos of x. And if you integrate both sides, then it would be d by dx is equal to integral of cos of x dx. Okay, so we're left with only b on the left side, and b is equal to cos of x, integral of cos of x dx. So integral of cos x actually sine of x, then only c, right? So now we have u, we have du, we have db, we have b, everything are ready. So according to the formula I can write, okay, so what is u? U is x. What is, let me write this function, this formula, integral of u db is equal to ub minus integral of b du, right? So b, what is b? B is sine of x, right? Then integral of sine of x, we don't need to write c here, and then du is equal to dx. Okay, so x of sine of x minus integral of sine x, which is actually minus cos of x, right? So cos of x plus c, so final answer would be x times sine of x minus into minus plus, so cos of x plus c. So this is the final answer for this example. Example 3. For example 3, we have a function f of x is equal to square root of x ln of x. Okay, so integral of this function square root of x ln of x dx. Now we need to take our u and db, right? So if you check, this is an algebraic function and this is a logarithmic function. Since logarithmic function comes first according to the rule of LIAT, so we can take u as ln of x. Okay, so we can write du dx is equal to 1 over x. Therefore we can write du is equal to 1 over x dx, right? And db is equal to square root of x dx. If you divide both sides by dx, then you would get db dx square root of is equal to square root of x, right? Then if you integrate both sides, then you will get integral of db dx and dx. This is because of integration is equal to square root of x, integral of square root of x dx. Okay, so final for this process, final answer will be b on the left side. B is equal to if you integrate square root of x, then you will get 2 over 3 square root of x cubed. Okay, square root of x cubed plus c. So now we have everything. We have u, we have du, we have db, and we have b. So first write the integration by part formula. So this is integral of u db is equal to ub minus integral of b du. Okay, so what is u? U is ln of x into b, what 2 over 3 square root of x cubed. Okay, then minus, first we can factor out this constant. Okay, constant multiple, so which is 2 over 3. Then we have only left with square root of x cubed, right? And then we have du. What is du? Du is equal to half 1 over x dx. So 1 over x dx, right? So if you simplify this expression, we will get, so 2 over 3 square root of x cubed ln of x minus 2 over 3. And here we need to consider one thing. See, we have x to the power. If we rewrite this thing, it would be 3 over 2. Then we have 1 over x, right? 1 over x dx. Okay, so I'm just writing this part, 2 over 3, and see, 1 over x means x inverse, right? X to the power minus 1, right? So x 3 over 2, and which is x inverse 1, x inverse, right? Okay, then dx. Okay, then this is this 2 over 3, and this, see, our bases are same, so x, and when we are multiplying, in case of multiplication, we need to add the power. So what we can do, 3 over 2 minus 1, so we are adding the power dx, right? So minus 2 over 3 x to the power, it would be 2, and 3 minus 2, which is 3 minus 2, which is 1. Okay, 1 and dx, right? So I forgot to put the integral sign. We need to put integral sign here. So integral sign. Okay, so we can write 2 over 3 square root of x cubed ln of x minus 2 over 3 integral of x to the power half dx. And if we simplify this, it would be 2 over 3 square root of x cubed ln of x minus 2 over 3, and if we integrate x to the power half, then it would be half plus 1. It would be 3 over 2 divided by 3 over 2, and finally we can add a c. So this is 2 over 3 square root of x cubed ln of x minus, so d over 2 over 3 divided by 2 over 3 square root of 3 over 2 plus c, this is 2 over 3 square root of x cubed ln of x minus 2 into 2 times 2 4, 3 times 3 9, and we can simply write it square root of x cubed plus c. So this is the answer for this example. This is kind of long process. So this would be our final problem for integration by parts. Okay, so example 4 is, for example 4 we have a function which is f of x is equal to x times 2 to the power x. Okay, so integral of this function x times 2 to the power x is this. So here what is u? Definitely u is x. Why? Because this x is algebraic function and 2 to the power x is exponential function, so we need to take x as u. So u is equal to x, then we can write du over du dx is equal to 1, therefore du is equal to only dx, because 1 into dx is equal to dx, right? So then our db is equal to 2 to the power x dx, and if we divide both sides by dx, then we get db dx is equal to 2 to the power x. Now if we integrate both sides, then we would get db dx is equal to integral of 2 to the power x dx. So on the left side we have only b, and on the right side we have integral of 2x to the power x dx. So what is the integral of 2 to the power x? We need to find out this. So according to the formula, if you check the formula, you will see it should be 2 to the power, x ln a, where here it is 2, so ln of 2 plus c. So this is the answer. So now we have bu, we have du, we have db, and we have b. So according to the formula, we can write, first write the formula for simplicity. So integral of u db is equal to ub minus integral of b du. So what is u? U is x, and what is b? B is 2 to the power x over ln of 2, right? So then integral of b is 2 to the power x ln of 2, right? Then du, what is du? Du is equal to dx. Simple. Okay, so I can write x times 2 to the power x over ln of 2 minus, see, ln of 2 is a number, so we can factor it out. So ln of 2 integral of 2 to the power x dx, and finally we can write our final answer would be x times 2 to the power x divided by, so we can simplify this expression. We can write x times 2 to the power x over ln of 2 minus 1 over ln of 2, and then integral of 2 to the power x, we know this 2 to the power x divided by ln of 2. Okay, ln of 2, and finally we need to add a c. So c, then see, we have one like terms which is 2 to the power x over ln of 2, so which is a common factor, so we can take it as a common, then we can write. So here on the left side we have only x minus 1 over ln of 2, so ln of 2, right? We can put a bracket and then plus c. So this is the answer for this last example of integration by part I'm giving you. Okay, so far we have solved a number of problems using integration by substitution and integration by parts. So in integration by substitution, I believe that I have solved 9 to 10 problems, and by using integration by parts, I have solved 4 problems. So I believe that now you have a good understanding on these two techniques to apply them in integration problems, right? So now I'll be giving you a number of questions like 3, 4, or 5, and first try to solve them by yourself and later check your work with mine. Question 1. So for question we have a function which is f of x is equal to 5x plus 4 all to the power 6. Okay, so integral of this function is integral of 5x plus 4 all to the power 6 dx. Okay, now we need to choose the proper technique. So in choosing your technique, first do one thing: always go for integration by substitution part. Integration by substitution first. So if it doesn't work, then only you can go for integration by parts. And from my understanding, from my experience, I found that this is a very good thing in choosing the in choosing the best technique of integration. So here we can take our u. So for u, let u is equal to 5x plus 4. So derivative of u with respect to x is actually 5. So du is equal to 5 dx, and we can write in a different way: du by 5 is equal to dx. Why I'm writing in this way, I'll tell you after some time. So now we have du, we have u, we have du, we have everything. Okay, so we can rewrite this expression again. So integral of 5x plus 4 is u, right? So u to the power 6. Here we have dx, but what is dx? From this we know dx is actually du over 5. So du over 5. See, simple. So you need to solve any kind of problems using your techniques from your understanding. So this is a very easy thing if you know the appropriate procedure, right? So we can figure out this constant. We can figure out this constant 1 over 5 integral of u to the power 6 du. Now what we can do, we can apply the power rule, and we can write 1 over 5. We can write 1 over 5, and using the constant multiple rule of integration, we can write u to the power 6 plus 1 is 7 divided by 7, and then just add a c. So we can substitute the value of u, which is 5x plus 4, right, to the power 7, and then we can write this 7 in the new denominator plus c. So our final answer would be 5x plus 4 all to the power 7 divided by 5 times 7, 35, right? Then plus c. So this is the answer for this first question. See, we start with integration by substitution, and it did work. So that's why we didn't go for integration by parts. So when your integration by substitution is working, don't go for integration by parts. Be fixed with your first technique. Question 2. So for question 2, we have a function which is x plus 1 all to the power 3. This is an algebraic identity. So integral of this function integral of x plus 1 all to the power 3 dx. So as I told you earlier, always try with integration by substitution. So let our u is equal to x plus 1, right? So when it is x plus 1, so du dx is equal to 1, therefore du is equal to dx, right? Okay, so we can represent our function with u and du. So integral of x plus 1 is u, right? So u to the power 3 and du is equal to dx, right? So du. So this is very easy problem. So we can integrate this u according to the power rule of integration. So u to the power 3 plus 1 is 4 divided by 4 plus c. So what is u? U is actually x plus 1, okay, to the power 4 divided by 4 plus c. So this is the final answer for this question. Question 3. So for question 3 we have one function which is f of x is equal to ln of 5x. So integral of this function ln of 5x. Okay, so now we need to choose our appropriate integration technique. So let's start with integration by parts as usual. So u is equal to take u equal to ln of 5x, okay, then du dx is equal to du dx is equal to integral of 1 over 5x using integration by chain rule of differentiation. So we need to differentiate the inner part now. So it would be only 5. So 5 will get cancelled, it would be 1 by x. So we can rewrite it again, du is equal to 1 over x, right? 1 over x times dx. Or I need to find out dx also. So dx will be du over, sorry, x times du is equal to dx. Why I'm taking this dx? I'll show it. Okay, so using these two u and du, we need to represent our this function. Okay, maybe in some cases we need to multiply with some constant or divide this function with some constant. Yeah, this can be done, but what kind of problem we are facing right now? See, so if you want to substitute them in the format, so it would be ln of 5x, it would be u, right? So then dx, we have dx is equal to, what is dx? X du, but here we are getting one extra variable. So you need to understand that we cannot use integration by substitution here to solve this kind of integration problem. So we need to go with integration by parts. So let me remove all this. Okay, so for integration by substitution, integration by parts, we need to choose two things, and one is u and one is db. So we have taken u already. See why we have I am saying that this is okay for u, because see, we have if I want to rewrite it again, I can write it integral of ln of 5x. This is only one function. I can make one more function. See, 1. Okay, so no change in the in the main thing. If you multiply with 1, then nothing will happen, everything is same. So now I can say we have two functions, right? This is logarithmic function and this is a constant, this is algebraic function. So according to this LIAT rule, we need to choose ln of 5x as u, because this comes first according to this rule, and then comes algebraic function. So our u is okay. So for db, I can take 1 dx, right? So if I divide both sides by dx, then I'll get db dx is equal to only 1. And if I integrate both sides, then I will get integral of db by dx and then dx. This dx for integration, right? This is integral sign, integral sign, and this is differential, right? So then I need to write 1, integral of 1. So according to this integrations format, I need to put this dx. Okay, so on the left side I have only b, and on the right side I have only x, right? and plus c. So now I have everything. I have u, I have what else? I have db, I have du, I have v. I have everything. So first I can write this integration by parts formula. So it is integral of u db is equal to ub, right? Ub minus integral of v du, right? So what is u? U is ln of 5x, and v is 5x minus v is x and du. So this is du. What is du? Here we have 1 over x dx, and see this x gets cancelled, right? This is simple. Then ln of 5x times x minus, and integral of 1 would be x, and finally I can put a c. So the final answer would be, I have x here, I have x here, so I can take as x as a common factor. So x, so on the left side I have only ln of 5x minus 1, then this c. So this is the final answer for this question. Question 4. So for question 4 we have a function which is 6x over 8x plus 5 all to the power 5. So integral of this function 6x over 8x plus 5 all to the power 5. Okay, so now we need to choose the best integration technique. So as usual we can start with integration by substitution first. So let u is equal to 8x plus 5. When I was explaining integration by substitution at the very beginning of integration by substitution, I have told you how to check this u, because you need to take u such a way so that by u and du you can represent your whole function, okay, whole integral function. So keep it in mind. So now I'm not explaining how to take u here. Okay, so I have taken u, so the derivative of this u is equal to ddx of u is equal to only 8. So we can write du is equal to 8 dx. And now I'm taking also dx, so dx would be du over 8 dx. Okay, so why I'm taking this thing I will tell you later. Okay, so now I have u, I have du. So for substitution these two things are fine. Okay, so using these two things we can write integral of, in the denominator we have u, so 8x plus 5 actually u, so u to the power 5, and dx. In place of dx, what we have? We have du over 8, right? We have du over 8, so we have du over 8, right? Du over 8, but we don't have 6x. So let's say we have 6. We can put 6, no problem, but we don't know x. We don't know our x. So we can find this x from this equation, So from this equation I can write u is equal to 8x plus 5, right? So adding 8x on both sides I can write, subtracting 8x both sides I can write u minus 8x is equal to 5, right? So then x would be minus 8x equal to 5 minus u, right? So I can write 8x is equal to u minus 5, and then my x is equal to u minus 5 divided by 8. So this is the x. So in place of x I can write this u minus 5 divided by 8. So and okay, so everything is fine. I can derivate this function again. I can factor out this constant 6, and now I can simplify this expression. So I can write, we have a 6 here, we have 8 here, so I can write 6 over 8 integral of u minus 5 over 8 times 1 over u to the power 5, right? Then du. So again we have 1 8 here, so 6 over 8 times 8 is 64, right? Then integral of u minus 5 divided by u to the power 5, then du, right? So 6 over 64, and I can put a third bracket, integral of, we can derive it, u over u to the power 5 minus 5 over u to the power 5. We can write it in this way, then du, right? So du, then we can write 6 over 64. So see, we have one u here, and we have 5 u here. So one u from both side, from both side will be gone. And okay, so I can write it integral of 1 over u to the power 4, because one u has gone already. Then dx, according to the difference rule of integration, I can write this. Then I can pull out this 5, this is constant. 5 integral of 1 over u to the power 5 and du, right? And then I can rewrite it again, 64. Okay, then I can this u to the power 4 in the denominator. If we want to write it in the numerator, then this power would be negative. So u to the power minus 4 du minus 5, again it would be u to the power minus 5, right? Du. Okay, so 6 over 64, third bracket. So according to the power rule of integration, it would be u to the power minus 4 plus 1. What is the answer? Minus 3. So minus 3 minus 5, and u to the power minus 5 plus 1, it would be minus 4 minus 4. Okay, so we can put a third bracket and we can put a constant c. So see, here we have one negative sign, they are get cancelled, and we can simplify it a little further. So we can write 6 over 64, third bracket. So minus what I can write, minus 1 over 3 u to the power 3, right? And then plus 5 over 4 and this u to the power 4, right? Then plus c, 6 over 64, and then we can take the common lowest common multiple, so it would be 12 u to the power 4, right? So 3 goes into 12 4 times, then we are left with only 1 u, so 4u into 1 is 4u, so minus plus 4 goes into 12 3 times, then 3 times 5, 15, third bracket c. So now we can substitute our u value, then it will be minus 4. What is u? So it is 8x plus 5 plus 15 divided by 12, 8x plus 5 all to the power 4, third bracket, plus c. So even we can simplify it, but I am leaving it here. I believe that this is in a compact form and this is fine. Question 5. So question 5. So for question 5, we have a function which is f of x is equal to 4x times cos of x. So integral of this function is 4x of cos of x dx. So now we need to start with our integration by substitution. So let our u is equal to 4x, right? And du dx is equal to only 4. So du is equal to 4 dx, and dx is equal to du over 4 dx. So we have u, we have du, so we can use them to represent this integral function. So I can write integral of 4x is actually u, and cos of x du. It should be, so what is du? Our du is actually 4 dx, but here we have cos of x. We are not getting this, so we cannot solve this problem using integration by substitution, we need to tie it with integration by parts. Since we cannot solve this problem by using integration by substitution technique, so we need to tie it with integration by parts. So for integration by parts, we need two things. We need u, we need db. So to choose u and db, we need to follow the rule LIAT. So according to this rule, 4x is algebraic function and cos of x is trigonometric function. So algebraic function comes first, comes before trigonometric function. So our taking u as 4x is fine. So now we need to take db. So for db, I can take db is equal to cos of x dx. If we divide both sides by dx, then it would be db dx is equal to cos of x. If we integrate both sides, then I would get db dx is equal to integral of cos of x dx. Then I can write b is equal to integral of cos of x is actually sine of x, right, plus c. So now we have everything. We have u, we have du, we have db, we have b. So first write this integration by parts formula. So according to this, integral of u db is equal to ub minus integral of b du, right? So what is u? U is 4x, right? So 4x, b is equal to sine of x, right? So then integral of b is equal to sine of x, and then du. What is du? 4d, our du is equal to 4 dx, right? 4 dx. Okay, so I can write 4x times sine of x minus, so integral of sine of x is actually minus cos of x. So and sorry, first I need to factor out this 4 constant, so I can write this 4, and then integral of sine of x would be minus cos of x, okay, then I can just put a constant c. So answer would be 4x times sine of x minus into minus plus, minus times minus time, plus 4 cos of x plus c. So this is our answer for this question. We have a common factor, so we can take it. So this is 4, so 4x sine of x plus cos of x, right, then plus c. So this is the final answer. We can try to solve one more question, and this would be our final question for integration. So question 6, this. Okay, so for question 6, let's say we have a function f of x is equal to e to the power x times sine of x. So what is the integral of this function? So integral of e to the power x times sine of x dx. Okay, so I can tell you I have checked this problem to solve with integration by substitution. Okay, but it didn't work. So you also try to solve this problem with integration by substitution technique. So try it first and then go with integration by parts. So I have to try, I have tried it already, that's why I'm not going to show this work again. So I'll be going through only integration by parts. Okay, so for this, see, we have two functions. This is exponential function, this is trigonometric functions. Okay, so according to the rule of integration by parts, which is LIAT, so since we have one logarithmic function, one exponential function, so our u would be sine of x, because it is a logarithmic function and it comes before exponential function, right? So if we differentiate this function, so du dx is equal to derivative of sine x is actually cos of x, right? Cos of x. So we can write du is equal to cos of x dx, right? So our db is equal to e to the power x dx, right? So if we divide both sides by dx, it would be db dx equal to e to the power x, right? And if we integrate both sides, then it will be db dx times dx is equal to integral of e to the power x dx, right? So v is equal to e to the power x, integral of e to the power x, you know, this is only e to the power x plus c. So now we have u, now we have du, db and b. So first let me write the formula for integration by parts. This is integral of u db is equal to ub minus integral of b du, right? So what can you write for according to this formula? So our u is equal to sine of x times e to e to the power x, right? Then integral of e to the power x, right? Then du. So what is du? Du is equal to cos of x dx. Okay, so we can simplify this function. So we can write, so now we can write we need to simplify this this expression, right? So I can write sine of x e to the power x minus see here we have we are having again one function where I need to apply integration by parts, right? So for this here see we have trigonometry function, we have exponential function. So for this part I can work separately, right? So I can write, okay, let me write it again here, e to the power x cos of x dx. So for this part only, so only for this part we can write our u is equal to e to the power x, right? Our u is equal to, sorry, u is equal to cos of x, right? So db dx is equal to minus sin x minus sine of x, and du is equal to minus sine of x dx, right? And our db is equal to e to the power x dx. If you divide both sides by dx, then we would get du dx is equal to e to the power x, and if we integrate both sides, then we get du dx times dx is equal to integral of e to the power x dx. Then final answer will be b is equal to e to the power x plus c, right? So what we can do now, I have written this original integral function again. So here we can start our working. So I can write sine of x e to the power times e to the power x minus, here we need to apply the integration by substitution again. So here we have our u is equal to what, cos of x, right? And our b is equal to e to the power x, right? Then minus integral of e to the power x, then our what is this, du, right? Our du is equal to minus sine of x dx, right? So now we can work on this. We can write sine of x times e to the power x minus cos of x. So this okay, this is minus, right? E to the power x, this minus and this minus plus, right? And sorry, minus into minus plus, plus into minus minus. So this should be minus. So this should be minus. Okay, so So I have taken this original function, our original equation already, so I can write this sine of x times e to the power x minus. So here we need to apply our integration by parts technique, right? So I can take a third bracket. So our u would be, what is our u? Our u would be cos of x, right? Cos of x, and our v is equal to e to the power x minus integral of our b is equal to e to the power x, right? And our d is equal to minus sine of x and then dx, right? So I can put a third bracket again. So I can write sine of x times e to the power x minus cos of x times e to the power x, and this, see here we have a minus times minus plus times minus, actually minus, so I can put a negative sign here. So now integral of e to the power x times sine of x dx, right? So if you check, here we have e to the power x sine of x dx, and here again we have e to the power x sine of x dx. So we can uh, we can add e to the power x minus sine x on on both sides, then we will get e to the power x sine of x dx. It would be 2. So if we add on right and left side e to the power x times sine of x dx, this on the left side we would get 2 e to the power x, right? So then I can write sine of x times e to the power x minus cos of x e to the power x. Then we can only write e to the power x times sine of x dx is equal to this sine of x times e to the power x minus cos of x times e to the power x divided by 2, because we have divided both sides by 2, right? Then we can simplify it a little further. We can take e to the power x as a common, e to the power x sine of x minus cos of x, right, and divided by 2, and put a plus c here. This is the end of the video. I believe that you have enjoyed the learning and found the way to simply solve differentiation and integration problems. Download the complete worksheet visiting description or comment box, and subscribe to my channel if you are in YouTube, or like my page if you are in Facebook.